at on a backyard patio that is 100 square feet. The cement comes out and of the truck at a constant rate, meaning it's not going to go fast, it's not going to be slow, it's going to be a constant rate poured out of that concrete truck. Now, it's important that he gets all the concrete poured before 12 o'clock because that's when it gets too hot and it starts to affect when the cement's mixed properly. Now, it's currently 11 a.m. and he has poured 75 square feet of concrete in the last 3 hours. At this rate, will he finish before noon? Well, first off, we've got to find a rate. And the rate that we've got to find is this. They gave us 75 square feet in 3 hours. That's 25 square feet in a what? An hour. Now, that's important to know because, ladies and gentlemen, 25 square feet in 1 hour is the constant of proportion. It's constant flow. Now, it is your rate of change. It's your constant proportionality, right? It's also a special rate that you need to know because look at the denominator. What is the denominator? What's the denominator, guys? 1. Anytime your denominator is 1, it is referred to as a unit rate, right? A unit rate. So, not only is it constant proportionality, it's also a unit rate. Let's look at our table. At time 0, have we poured any concrete? We don't start counting time until we start pouring. That engine revs and he gets that mixer going and turns it loose to come down that chute, right? So at time 0, we ain't poured nothing. But in 1 hour, we poured how much? 25. In 2 hours, we poured how much? 3 hours. 4 hours. All right. If we look at the change in X, which is the X values over here, this triangle looking thing beside the X, it's referred to as delta. It's a Greek letter. You can look at them when you drive down Village Avenue in Athens. They have a bunch of Greek letters up for fraternities and sororities. Now, the triangle means delta, and delta means change. So it's the change in X. So when I go from 0 to 1, I'm moving 1 spot. When I go to 1 to 2, I'm moving 1 spot. 2 to 3, I'm moving 1 spot. 3 to 4, I'm moving 1 spot. Good. It's constant down the X side, would you say? All right, let's look at the Y. I have a change in Y. 0 to 25 is how much change? 25. 25 to 50 is how much change? 50 to 75 is how much change? Good. 25. 75 to 100 is how much? So your change in Y is also constant. All right? So the numbers down the left-hand side as far as change, the numbers down the right-hand side, change in X, change in Y, they're constant. So it has a constant rate of change, okay? When that happens, it is said to have that is a constant of proportionality, all right? You learned it back in 7th grade as being a cop, or you should have referred to it as a cop, okay? Now, when you graph these, I graphed them. I put 0, 1, 2, 3, 4 on the hours on the X, and I put 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 on the Y, and I labeled this Y as square feet, as you can tell in the drawing. Now, and I labeled my X-axis hours. I put a dot at every one of these ordered pairs. So I got 0, got 25, got 50, got 75 on the Y's, and then corresponding X matches with them. If I were to connect those dots, what would it form? What would it form if I connected those dots? A triangle, a circle, a trapezoid. What would it form if I were to connect the dots? Go. No, not a rectangle. Look right here. Let's look at this. If I connected all them there dots, what would it form? A what? Yeah, what about that line? It's a straight line, right? And you go, well, Palmer, most lines are straight. You're right. But for you to say a straight line, that's what you need to know. So a constant rate of change, a constant rate of proportion, a unit rate when it's 25 over 1 will produce a line, a straight line. Because for every change in x, it's going to be a set amount change in y. And you're going to continually do that over and over and over. And what it's going to do is change the same, which will make a straight line. Okay, that's the big thing. Now, do you see my red here? How much did I go up from this dot to that dot? I went up to 25. And then how far did I go over? Okay. How did I change in my y's? 25. How much did I change in my x's? Yeah. Coincidence that I see it over here? No. Because that stair step is the constant of proportionality, the constant rate of change for that problem. So not only have we seen it in a table, we have also seen it in a graph. We have analyzed it all forms, right? And we're going to get to an equation in a little bit. Now, for it to have a proportional relationship, it must, one, have a constant of proportion, right? A constant rate. That's one criteria. The second criteria is this. You see that 0 down there? What does that 0 represent on that graph? The origin. It must pass through the origin in order for it to be a proportional relationship. Fair enough? So those two things. Questions? All right. So just curious, what's the unit rate for the relationship? 25 over what? 1, which is what? 25. Now, they said, which equation best describes the relationship? Well, if I told you this, if I told you y equals the COP times x, and sometimes you'll see it like this. Y equals kx. It's nothing more than the y and the x, and the coefficient of the x is the constant of proportionality, or the unit rate. So which one of these would be the equation for the problem that we just worked? Would it be C? Well, let me ask you this. How many, let's do a show of hands. How many of you think it's A? Okay, how many of you think it's B? C? D? Okay. What is the unit rate or constant of proportionality for the Doug pouring the concrete? What's the COP? What's the COP? Huh? 1? What's the COP? Look at the 25. Right? So all you have to do is take the COP and replace and put it in front of X, right? So with that understanding, let's survey the crowd again. How many of you think it's A? How many of you think it's B? How many of you think it's C? How many of you think it's D? How many of you don't have a clue? Then you need to pay attention. Ladies and gentlemen, look at the equation. I said y equals something, constant proportionality, times who? Okay, now, so let's look at our choices. It's definitely not C, because it doesn't say x equals 20, the constant proportionality times y. It doesn't say that at all. It says y equals the constant proportionality x, right? That's what you got to make sure you understand. No, that's y equals. See that? Y has a tail. X is just crisscross applesauce. All right, so here we go. We're going to look at some stuff. And the first thing we'll look at is this problem. Now, where did this problem come from? This problem came from this sheet right here. So, Ruiz, hand that out. Give everybody one, please. When you get this problem, excuse me, you need to start working it. So, don't talk to your neighbor. Just start working it. That's what you need to do. We'll pause it here for a second, let you look back on this problem or start looking at it. First things first, you need to analyze the table, because analyzing the table will help you to understand some things. This is the x, so we're going to say change in x. This is y, so we'll say change in y. We basically need to understand how are my x's moving. So from 2 to 3, 3 to 4, 4 to 5, 5 to 6, how are they moving? 1. Bless you. Bless you. Now, how are my y's moving? Yeah, is it positive 2 or negative 2? How do you know it's positive 2? Well, no. The numbers are increasing. As you progress down the y's, the numbers are getting bigger. They're getting bigger by 2 every time. Now, what is the constant of proportionality, ladies and gentlemen? It's as simple as this. Change in y over the change in x. Sometimes people just say y over x, right? Y over x. It's really more than that. Let's look at the change, because it has to be constant, right? So, that is 2 over 1, right? 1, which is nothing more than what? 2. But I'm going to put 2 over 1 right there. And the reason why I'm going to put 2 over 1 is it's showing that it is a unit rate. Okay, it's showing that it's a unit rate. So, okay, so is it proportional? Yes or no? How do you know? No? Is it proportional? Yes or no? Oh, I'm blocking you. I'm sorry. I do apologize for that. Good move. Okay. Well, let's plot them, because I like to plot things, you know. 2, 4, 3, 6, 4, what? 8, 5, what? 10, and 6 is what? Okay, good. If we connected those, what would it create? What type of line? Why is it a straight line? Go ahead. Why is it a straight line? Yes, you're correct with saying proportional. Give me a little bit more of an answer. Can you build upon that? That's exactly right. Your change in y and your change in x are constant, right? They're constant, meaning they're moving at the same rate or amount every single time. If you think about this, here I am. I'm on this grid on this floor, right? If I go up 2 and over 1, and then up 2 and over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, all the way, if I put a dot at each one of those points, and connected them, I would make a line because I'm going up 2 and over 1. I'm going the same amount of change every single time in the y and the x. So it makes a difference. Now, is this proportional? Yes or no? Is it proportional? Yes or no? Yes? Why? Well, raise your hand. Well, I got one halfway. All right, raise your hand if you think it's no. Okay, I got a yawn and then I got 2. But raise your hand if you don't have a clue. And we have the yawn again. Yep. Oh my. Now, so we only had just a couple of people raise their hand, and I asked the question, did you know? Did you not know? Basically, is it or not? And then who doesn't have a clue, right? And y'all just like this. Okay. Now, so that's not good enough for me. See, you got to know what you know what you don't know, and get your unknowns known. So either you know it or you don't know it. That's right. So is this proportional? Yes or no? Yes. Raise your hand for yes. Raise your hand for no. Why are y'all saying yes? Okay. All of the rates of change are all the same. Okay. That's great. Okay, first off, about less than 10 minutes ago, I said it takes 2 things for it to be a proportional relationship. One of them was a constant rate of change, so you've hung your hat on just one and said, it's that. No. See, there's 2 things that have to happen in order for you to say you have a proportional relationship. It's got to go through the what? Well, see, I didn't pass out no rulers because then y'all would be sitting there spinning them like a helicopter. That's right. See, y'all doing it right now magically. I know. Take your hood off. Some beautiful hair. Show it. Now, you don't have a ruler, right? And you go, well, Mr. Palmer, I can do this right here. Well, yeah. That looks like a mountain road by the time, because you can't draw a straight line. I'm sorry. Son, it's not straight. There you go. Now, how am I going to be able to determine whether that goes through 0 or not if I don't have a ruler and I can't draw a straight line? You got 10 seconds to be able to think about it and tell me how you going to be able to figure it out. Go. Yeah, you're on the fork of the road. I don't know if you're kind of headed in the right direction type thing, but I'm not. Don't have enough information to say yay or nay. Oh, I forgot to ask. Wow, she brings out the ruler. All right, don't spin it. Don't spin it. Now, ladies and gentlemen, look at me. This is great because I'm gonna show you something. If I go like this, that meant I went up 2 and over what? Up 2 and over what? Up 2 and over what? And then so forth and so on. Okay, so if I can go up the stairs, I can also go down the stairs. Watch me. Ready? So I'm going to go over and what? Down. I went over 1 and down 2, right? Over 1 and down what? Ladies and gentlemen, all I done was took my constant of proportionality, said, oh, it's changing 1 in the x and 2 in the what? Why? I'm changing 1 in the x and 2 in the what? That's right. You said it was like that. Now look at my steps. They're nice and pretty, right? So if you go up the steps, you can go down the steps. Does it go through the origin? Yes, it does. Ladies and gentlemen. Yes. Now, no, y'all just said that's right because y'all good guessers. I didn't hear the correct answer yet. One time I thought I was wrong, but then I was right. So, it was that one time. Now, I want to know the equation. Ready? Ready? Go. Tell it to me. Y equals what? Oh, but I'm not going to say x times 2 because that's not how I just formatted it in the previous problem. Y equals what? 2x. Good job. Now, how can I check this, ladies and gentlemen? How can I check that that is the equation that will produce this table and goes with that line? I can replace each x value with the 1, 2, 3, or 4, right? The values within the x's, right? So if I take 2, plug it in for x, what's 2 times 2? 4. Did I get 4 out? Yes. How about 3 times 2? Okay, so it works, right? I double checked it. Great. Now, here's what I want you to do, nerds. Do number 2. Do number 2. Go. Right here. Number 1 problem. I guarantee if you look on your partner's paper, I guarantee they do not have this right here. Oh, they got this right here, little stuff like that. But they do not have the change in x and the change in y. They don't have it on it. You know why? Because they feel that it is not important. And ladies and gentlemen, they have missed the boat. They're on the dock, and everybody's waving. That is important. You have to understand what change you're looking at. You have to understand that. What? Now, how is my change in my x? How's the change in my x going? By 1s, right? You agree? Now, how's the change in my y's? 2. Now, I wish they didn't give me that problem. Because it's 2 of them using the same changes, right? We ought to mix it up. So that's a bad problem to follow. But anyway, what is my constant of proportionality? Change in y over change in x, which is 2 over what? Now, most people will just say y over x, right? They'll say y over x. Okay? But I want you to get in terms of thinking change. Because that's really what that number's represent. How's it moving? How's it moving, right? So, ladies and gentlemen, when we go to plot these, which is a really good thing, so I go 1, 6, 2, 8, 3, 10, 4, 12, there. Okay, if I were to connect those dots, what would I make? A straight line, ladies and gentlemen. Is that proportional?
Yes.
All right, raise your hand for yes. Raise your hand for yes. All right, raise your hand for no. Now, why do you say it's no? Why? Go. It doesn't start or it doesn't cross at the who? Right. So let's check it out. Watch this. This is pretty cool. I like this. Up 2 over 1, up 2 over 1, up 2 over 1, that's 2, and there's 1, there's 2, there's 1, there's 2, there's 1, right? Yay. So if we can walk up the stairs, we can walk down the stairs, right? So I'm just going to go over 1 and down what? Over 1 and down 2, right? See, my y's, which go this way, because y changes by 2's. Now, so no, it's not proportional. Now, my question is this, whippersnappers. What is my equation? What is my equation? Y equals 2x. Okay, hold up. Let's check this. Let's check, because we checked the other one, did we not? So let's check it. If I plug 1 in for x, what is 2 times 1? But it says we ought to have a what? Well, maybe we made a mistake. Let's try another one. 2 times 2, right? Plug the 2 in for x. 2 times 2 is what? Is 4 the same as 8? Oh, so we're 2 for 2 being so y equals 2x is not the equation. The constant of proportionality is 2. I 100% agree. 100% agree. Now, watch this. Look at that. If it doesn't cross through the origin, then you need to put plus or minus that point where it crosses, right? Because let's check it. 2 times 1 is what? 2 plus 4 is what? Does it give me what I need? Yes, it does. Let's try it again, because, we may have performed a coinkydink, right? So let's do it again. 2 times 2. What's 2 times 2? I don't know. Is this dance-off time? I now appear on the stage for America's Got Talent.
I love being Simon.
What's 2 times 2? 4 plus 4 is what? 8. So it gives me 8. Ladies and gentlemen, if it does not cross the y-axis at the origin, then you have to attach where? Yeah, that's right. What? No, ma'am. You got to put the constant proportionality times x, then where it crosses, right? And if it crosses at 0, then if I add 0, if I do plus 0 to anything, it doesn't change anything, does it? That's why it's just y equals COP times x. All right, so you got this. Oh, yeah. Okay, go. We'll do half of this one, and then we'll get started. I just want you to look at the COP, and then you can go from there. And the graph. Now, gentlemen, boys and girls, first thing, changing x, changing y. Boom. Now, the constant proportionality is changing y over changing x, which is 2 over 3. Now, note that my constant, constant proportionality does not have a denominator of 1. How do we make it have a denominator of 1? You have to. We have to put it as in terms of a unit rate. Nope. Folks, it's a fraction. So divide. What's 2 divided by 3? No. 2 divided by 3 is not 1. No, it's not negative 1. Two-thirds is a fraction that is 0.66666, which really goes to 0.67. Ain't nobody marking you, so get off your high horses. I'm just talking fractions and repeating decimals, folks. Now, 1/3 is 0.333333. Excuse me. So, no, honey, those are certain fractions you ought to know. A quarter, a half, 3/4, a third, and 2/3 are fractions you ought to know as decimals. Period. You might want to Tattoo that to the back of your eyelids.
I thought you looked it up and spent the whole time reading. So I was like,
Nah. Now, let's do this. 3, 2, 6, 4, 9, 6. Right there. And then 12 what? 8. Now, ladies and gentlemen, I put them dots there, but what do I need to check on my graph? Because I got a lot of people that hadn't even written it the first time. You got to make sure what? Okay. Now, yeah, you get coughed up on that. Okay, you ready? You've got to check your constant of what? So let's check it on here. I went up 2 and over what?
3.
Up 2.
3.
Up 2.
3.
And over 3. Good. Now, how would I be able to know that it went through the origin by doing the stair steps? Go downstairs. You know it's time to go eat. Let's go downstairs. So we're going to go over how many?
3.
And down how?
2.
Thank you. So do I cross at the origin? Yes, I do. Ladies and gentlemen, it has a constant rate of change, and the constant rate of change on the graph, we were able to back it up, and yes. Now, let's write an equation. Dude, you already know it. It's this number times x. But do I have to put it over 1? No. So it's 0.67x. There you go. That's it. That's all you got to do. Now, listen up. We will learn later. I ain't done. Whoa, slow your roll. Slow your roll there, young folks. Now, what you're going to learn is within the weeks to come, 3 to 4 weeks, that when we get into the full-blown linear equations, that we don't have to look at it in terms of a unit rate, because we'll be dealing with linear equations that are not proportional. They don't have a proportional relationship, meaning they don't go through the 0, 0, the origin, right? They'll go through some other place on the y-axis, right? And that's okay. And if when you do that, you would just leave it as 2 over 3, right? You will leave it as 2 over 3 with an n. Now, what do I need to do? Well, I ain't done yet. 4 for homework plus the back. But what do you notice about the graphs of proportional relationships? The graph of a proportional relationship is a what? What is it?
Straight line.
Yeah. You bad children. A straight line. A straight line. Oh, it passes through the who? Now, listen. Listen to me. Because I'm sorry. We have all this rudeness. Now, stop moving and look at me. See, I told you that there was 2 conditions that had to be met in order to say that you had a proportional relationship. One was it had to have a constant rate of change, a constant ratio, which in doing so will produce a straight line because you're going up and over a same amount. Now, the other thing was that it had to go through the origin. Ladies and gentlemen, you have the back to do.